So in this little video sequence, is probably going to have to be broken down into more than one video. We're going to look at diploma questions and try to figure out how you can determine a question. I'm not going to actually do the full questions. I don't want to ruin the fun of figuring them out for yourself. I'm going to show you that there's a fairly limited number of combinations of ways to get to an answer. But there are enough of them that memorizing your way to it isn't going to help you out. So in thermochemistry, it's all about energy. And so we're worried about energy. We have potential energy, which will be equal to the kinetic energy, where the kinetic energy would be like your calorimeter change, and your potential energy might be a Q or a delta H, and the delta H might be given to you, and the number of moles times the molar enthalpy will equal the Q, so the N delta H, the number of moles times the molar enthalpy equals MC delta T. There are lots of ways that you can arrive at a correct answer, and it can be intimidating and it can be confusing. So what we're going to try to get at in this question is, how do you figure out which strategy to use? And so all I've done is stolen, basically, questions that are published online, and we're going to try to interpret the diploma questions and figure out how we would get to an answer. And so again, remember, there are lots of different combinations, but realistically, there are only so many ways to be able to get to the right answer. And so first of all, every time I do a diploma question or read a question, I'm looking to see what they're asking for. And with a numeric response, I don't have answers that are provided to me, but they will give me some idea of what I should be going for. So this says the enthalpy change for 1 mole of hydrogen sulfide during the Claus process, expressed in the scientific notation, is this. The values for A, B, C, and D are. So now, significantly here, we want kilojoule per mole, and the reaction is giving me the enthalpy. We're talking about hydrogen sulfide, and here, because they've given me this is essentially the delta H of the reaction. If I could divide that by the number of mole, I would have the molar enthalpy. And so they have given me an enthalpy, and I know that the coefficient belongs with this. So I'm going to just simply take this number divided by this number and express it in the fashion that they want. So sour gas is a mixture of predominantly methane gas and hydrogen sulfide gas. The Claus process can be used to determine the hydrogen sulfide gas from. So they've given me no experimental evidence to work with, so I can only use the reaction. They give me reaction enthalpy and the molar amount, so I can calculate that fairly directly. In this question, again, so this says the student determined the molar enthalpy for formation of carbon dioxide. Well, you can see that the units are kilojoule per mole. So I need to have an amount of energy divided by the number of mole. The question is this enthalpy going to be how will we calculate the enthalpy, and how will we get the number of mole? So then I have to go back into the question. Student experimentally, so this is significant, it's experimental, so I'm expecting that that's going to be an MC delta T, because it's an experimental value. It determined the molar enthalpy of formation for carbon dioxide by burning 1.04 grams of carbon. Now, that's not the mass of carbon. That's going to give me the number of mole, right? So the number of mole is mass divided by molar mass. That's how I'm going to get my N delta H equals MC delta T. The student found that burning the carbon released enough heat to increase the temperature of 1 kilogram. So that's my mass of my water, specific heat capacity of water, delta T. And so my delta H equals the MC delta T divided by the number of moles calculated through molar mass. So here you can see that they've given me two different masses, and it's one of those situations where I need to be aware of, how do I get the N and how do I get my mass? And it's fairly straightforward if you can organize yourself, right? But if you're not organized, you're going to get lost. Next question, I can see looks like it's a Hess question, but I'm not sure. They've given me multiple reactions, so it looks like it could be a Hess. According to the equations above, the enthalpy change for 2 and So if I look at this, I've got two of these, but I don't have this reaction, exact reaction. This is a Hess question, right? So it is a Hess question. And it's important to note that all of my answers are only kilojoule. They're not kilojoule per mole. So this is a straightforward Hess where we're just calculating the delta H for this. So I'm going to have times 2 of this. I need this in the products, so it's going to become a positive value. And then I'm going to balance out my waters so that they are in the correct state, because you can see our water is a liquid here. That'll be my strategy for that question. The next question that we'll look at is here. You can see that they've given me a reaction and an enthalpy. It says the energy that is transferred when 69.1 gram of xenon tetrafluoride is produced. Now, my units are kilojoules. I've been given a mass. So I can, as soon as I see that, I know N equals mass divided by molar mass. That's how I'm going to get my N value. N times delta H equals Q. And they're just asking for energy. So I've got this value for 1 mole of this. So the delta H is going to be equal to negative 251 kilojoule per 1 mole. That's going to be the value I use here. I calculate my N, multiply them together to get my Q, which is in kilojoules. The next question we'll take a look at, and then we'll break the video up, is this, the molar enthalpy of reaction. So they tell me it's molar enthalpy of reaction, and all of my units are kilojoule per mole. So if it's kilojoule per mole, I have to have the delta H divided by N somewhere. Now, this N could be experimental, and the delta H could be experimental, or if they give me the delta H of the reaction, this is the coefficient amount. And so we're talking about nickel oxide. So 3 mole of nickel oxide gives me this amount. So I'm going to take this number divided by 3 will give me my enthalpy. And the other wrinkle to this is it endothermic or an exothermic process? This is in the product, so it's exothermic. So I automatically know it could only be answer C or D. And since it's this number divided by 3, it's going to be C. Okay, I'll make another video continuing this process. Hopefully you're catching this. But if you're watching, there are only so many ways that we can get to a correct answer. We'll do more practice on these and try to help you focus your eyes so you can see what to do when you look at a question.